here's the algorithmic idea for the Tower of Hanoi. What we have is our 3 pegs, and we have, some stack of disks on the pegs. To move this stack of disks to another peg, the first thing you do is you pick up the top of the stack, right? You pick up all the disks on the stack except for the bottom one, and you move them. Right? As simple as that, right? That's what we would like to do. Logically speaking, in an abstract sense, what we would like to do is take the disks that are on the top, get them out of the way so that we can access the disk on the bottom and then move it. Okay. Now, actually doing this is easier said than done, and I walked through an example of how that works in the previous slide. But how you actually do that is kind of up to the algorithm. But logically speaking, what you want to do is you want to get rid of these disks, move them so that you can get this one and move it over to another peg. All right. So once we've done that, now we've gotten the bottom peg moved, or the bottom disk moved, and then what we need to do is move these back. Right? So let's just think briefly about how we move them back. Well, the first thing you need to do, you don't want to put all those other disks on this big one. So the first thing you need to do is get these 2 out of the way. Right? So to get these 2 out of the way, what do? Well, you can't pick up a stack of disks. Well, you say, I am eventually going to get this one out of the way. And then, to do that, I have to get these ones out of the way. Well, I can't do that yet, so then I'll just say, eventually, I'm going to get this one out of the way. And I'll start by moving this one. So what do? I move this one. Okay. I happen to land it over there. Right? So now once I've moved that one, I say, now I see what I can do. I can move that green one. I can get this one out of the way. And then what's next? Well, let me complete. I need to actually finish the job I started. Let me complete moving that stack of the top 2 disks. So I'll move him over here. And so now what do I have? Logically speaking, I have moved this small stack off of this medium stack so that I can take this one and put it where it needs to go. Put it in its final destination. Okay, final location. And so now what do I need to do? I need to move this stack back over here, but I can't do that directly. So to do that indirectly, first I have to get that little disk off the top, out of the way, so that I can move the green one. Whoops. And then once I've moved the green one, I move this. Okay. So logically speaking, what this algorithm is doing, what this disk stack moving approach is doing, is the following. And I'm going to write this as a very informal algorithm. Okay. So if I have a stack of disks that I want to move, so I'll call this the Tower of Hanoi, TOH algorithm. If I have a stack of n disks, and I want to move them, first I ask the following: is n 1? Right? If there's only one disk, then I'll just directly move it. Right? So if n is 1, then move the disk to destination. Okay. Otherwise, if n isn't 1, then the first thing I have to do is get rid of the top n minus 1, right? Get rid of everything except the bottom one. Okay, so move n minus 1 disks, and then move the bottom disk, and then move those n minus 1 disks back on top of wherever I put the bottom disk. Okay, and that's the procedure I just illustrated above. If I want to move this whole stack, then logically speaking, what I have to do is eventually I have to move the bottom one. So to do that, I've got to get these ones out of the way, right? So what I'll do is I'll move these ones out of the way, then I'll move the bottom one, and then I'll move these ones back. Okay, and then there's a bunch of intermediate steps, but logically speaking, that's how you move n disks. Okay, first you move n minus 1, then you move 1, and then you move n minus 1 again. Okay, so here's the completion of this very, very informal algorithm. So if there is more than one disk, then we have to do the following. First, we have to make a recursive call to our algorithm. We have to say, hey, algorithm that moves stacks of disks, first get rid of the top n minus 1. Okay, so first TOH the top n minus 1. So I'll just write n minus 1 disks. Okay, so first get rid of those, right? So this is here's my comment symbol. This is the top n minus 1 disks. Okay, and then what we do is we move the bottom disk, right? Just move it directly because we can do that. That's one of our primitives. So we move the bottom disk to its destination. And then we go back and we make another recursive call to this algorithm, and we say, go find those n minus 1 disks that you got out of the way and put them back on top of the new location of the bottom disk. So we Tower of Hanoi, n minus 1 disks again. So now move the top stack back. Okay. And there's our algorithm. Okay, so this is logically speaking the approach to solving the Tower of Hanoi. Okay, so how do we analyze this? So let's analyze. Well, what do we do first? We identify an input size. Well, this is the number of disks in the stack, right? So n equals the number of disks. Okay, what do we do next? We identify a basic operation. So the original question was, how can you do this in the fewest number of moves? So let's just call a move the basic operation, right? So basic op is one move. And then 3, set up a recurrence relation. Okay, so what's our recurrence relation? Well, we want to understand how many moves does it take to get a stack of n disks from one peg to another. And we can actually just read it directly off of this. Okay, so this here is our T of n, right? So when I call this, it's going to make as many moves as it takes to move a stack of n disks. This is our base case, right? So this says if n is 1, then we have one move to make. So this one says T of 1 is 1. This one says that if we aren't at the base case, right? So if we're somewhere higher up, then we have to make as many moves as it takes to move a stack of n minus 1. So this is a T of n minus 1. This is another 1, right? Another 1 move. And this is another T of n minus 1. So what's the complete recurrence relation? It's the following. Here, I'll write this down on the bottom line just so that it's clear. So what is this? This is T of n, right, which we get from right here, equals T of n minus 1 plus T of n minus 1 plus 1. Plus T of n minus 1 plus 1. All right, and then our base case is T of 1 equals 1. All right, what does this mean? How do we interpret this? Let me move that out of the way a little bit, and I'm going to focus on this a little bit. So the way we interpret this is we say this here, this is the number of moves to move a stack of n. These two things are the number of moves to move a stack of n minus 1. And when we're thinking recursively, we're not thinking in deep detail about exactly what's happening in these calls. We're just trusting the recursion to get it done for us. And the same thing works with the recurrence relation, right? I don't know the expression to put in there. That's the whole point of this, is that I don't know what the function t of n is. So I'm just going to make a recursive call to it and proceed, right? And I'll deal with the analysis later. So what this is doing is these each are the number of moves it takes to first get that stack of n minus 1 out of the way, and then once we've moved the bottom disk, to move it back. All right, so this is the number of moves to move the stack of n minus 1, top n minus 1 disks. And then this is move the bottom disk. All right, and there we go. That is our recurrence relation, right? And so in the next video, I'll pick this recurrence relation apart. We'll analyze it, and we'll see if we can learn any lessons from it.